Let's continue by looking at other if-then statements and see if we can reason through them in a similar way. Here's another one I made up for us um, to analyze here. If I keep riding my bike to school every day, then my family will pay less in gas for our cars. Okay, so let's carry that over to our little table here. Again, two statements. I kept riding my bike to school every day. My family will pay less in gas for our cars. You may have noticed I switched these to trues and falses as opposed to yeses and nos. I wanted to kind of get back to the language of logic, in which things are true and false, not so much yeses and nos. I rode my bike to school every day. Okay, let's suppose that's a true statement. So I did ride my bike to school every day, and then my family paid less in gas for our cars. Well, if that was what my original statement was, I did that, and the conclusion happened as I thought it would, I would probably think that was a fair outcome. Suppose I rode my bike to school every day, but my family didn't pay less in gas for our cars. That would feel unfair if I was told this. That's the kicker. If I was told this, and this happened, I did ride my bike, but didn't pay less in gas, I would feel that something unfair had happened. So far, I think both of these results make sense based on this condition. The tricky one, top right corner. Suppose I didn't ride my bike to school every day, but my family did pay less in gas for our cars. I know that doesn't make any sense for a whole host of reasons based on this statement, but I have to put something here. It's got to either be a fair or unfair. It's logical. It's got to be binary. It doesn't feel unfair, so by default, I'm going to call it fair. And again, I know that probably is the one that feels the weirdest of all of these, and it should, and we're gonna attack that feeling later. But if I have to call it either fair or unfair, it doesn't feel unfair, therefore I think it's fair. Think Sherlock Holmes in that case. And last but not least, if I didn't ride my bike to school every day, and my family did not pay less in gas for our cars, I still think that's fair. So once again, it's the same arrangement. Smiley face, frowny face, smiley face, smiley face. Okay, let's look at another if-then. Same kind of idea, another if-then. If I practice every day, then I'll get better at drumming. Okay, I practiced every day, either true or false. I got better at drumming, either true or false. And I understand that both of these statements in and of themselves are pretty loosely defined logical statements. I mean, practice, well, not all practice is considered equal, and the word better is extraordinarily subjective. But don't worry about that. Let's just treat them either I do or don't practice every day, and either I do or don't get better. They can be viewed as at least superficially logical. Okay, let's suppose I practiced every day, and I got better at drumming. Well, again, that's going to make me feel fair. That's good. I feel fair about that. But what if I did practice every day and I didn't get better? Well, again, I think this column is making sense. If it goes true, true, then we're feeling good. If it goes true, false, then we're feeling bad. Okay, it's the other column over here that's the oddball. What if I don't practice every day? Well, if I don't practice every day, let's take a little more global approach at this. If I don't practice every day, then really all bets are off over here, right? If I don't do what I said I was going to do, I can't complain about either of these results, whether I like it or not. So it seems that they're fair. I'm going to call them both fair again. I mean, if you don't do your part, you have really no vote over here. You can't say something's unfair if you don't satisfy your part. So I think it makes sense to call these fair. The only unfair is here. And as a matter of fact, you may have noticed that every single if-then follows the same pattern. If some hypothesis, then some conclusion. Hypothesis, conclusion. And every one of the charts looked like that. Now, this is great, except nobody actually uses logical charts that have smiley faces and frowny faces in them. So what is usually used in formal symbolic logic is, we're going to start with our if-then statement. If, hypothesis, then conclusion. And logicians do not write out the words hypothesis and conclusion. What they usually use are letters P and Q. If P, then Q. I can't tell you why they use P and Q, they just do. What logicians then do, once they've established if P, then Q, instead of having a 2x2 table with smiley faces and frowny faces, they create what's called a truth table that looks like this. Now, I want you to look at this and realize how it's the same thing as the previous 2x2 tables. They just list all the possible combinations of true and false for the hypothesis and the conclusion. So if the hypothesis is true and the conclusion is true, then the overall statement is true. That was our top left corner in our previous boxes. If the hypothesis is true and the conclusion is false, our conclusion was false. Now, notice I'm shifting the words true and false to mean fair and unfair, trying to make peace with the language of logic. Once the hypothesis is false, it doesn't matter what the conclusion is. We have to call it true because we defined it to be fair. Now, in closing, I don't want you to get freaked out or worked up about these truth tables. They're not that bad. The big thing is, this is the important row because it's the only row where the entire statement can be deemed logically false. And honestly, if you're at peace with these first two rows, then you can kind of ignore the last two, because the first two are really the only ones that matter in a logical context, because that's the ones where you satisfied the hypothesis. All right, I think that's enough to get us started. Let's give this a shot in the homework. We'll see you soon.